Hello everyone, welcome to Medivice. In this video, we're gonna be exploring the topic of oxygen transport, a very interesting topic. So let's start. So first of all, you should know that there are two forms in which oxygen is transported. We have the dissolved oxygen and hemoglobin bound oxygen. Dissolved oxygen, as the name tells us, is dissolved in the plasma, and hemoglobin bound oxygen is attached to the hemoglobin. Dissolved oxygen represents about 1% of the total oxygen, and rest 99% of the oxygen is transported by hemoglobin. First of all, let us discuss the dissolved oxygen. So it is about 1% of the total oxygen, and very importantly, it is the dissolved oxygen which produces the partial pressure. It is not the hemoglobin bound oxygen. The dissolved oxygen in blood is calculated using Henry's law. Now, what does this law tell us? So, dissolved oxygen is a product of solubility and partial pressure of oxygen. Solubility here is a constant. So, really, the only thing that is going to change is the partial pressure of oxygen. So, in this equation, DO2 is dissolved oxygen, solubility is 0.003, and partial pressure in arterial blood is 98 mmHg. So in order to know the dissolved oxygen in arterial blood, we will multiply these two numbers and we get a figure of 0.29. So 0.29 ml of oxygen is dissolved in 100 ml of blood, or 1 deciliter. Now if I ask you, what is the dissolved oxygen in venous blood? So again, using this equation you can calculate it, but you need to know the partial pressure of oxygen in venous blood. So it is about 40 in venous blood. So if we will multiply, we get a figure of 0.12 ml per deciliter. Now coming to hemoglobin bound oxygen. So this is about 99% of the total oxygen. Here the oxygen reversibly binds to the hemoglobin. As you must be knowing, hemoglobin has 4 binding sites. And if all the 4 binding sites are occupied, we will say that the hemoglobin is 100% saturated. You should also know that hemoglobin in arterial blood isn't exactly 100% saturated, it is about 97% saturated. Now, I know that doctors don't like to play with a lot of numbers, but we have to learn a few numbers here. So, 1 gram of adult hemoglobin can bind 1.34 ml of oxygen. Now, the concentration of adult hemoglobin in blood is 15 grams per deciliter. So, if 1 gram of hemoglobin can bind 1.34 ml of oxygen and there is 15 grams of hemoglobin, we can find out the oxygen binding capacity. We will multiply the two figures and find out that 20.1 ml of oxygen is transported using hemoglobin. But two things that you should know. First of all, this is per 100 ml or per deciliter. Secondly, this is when hemoglobin is 100% saturated. But in the arterial and venous blood, the hemoglobin is not 100% saturated. So in arterial blood, here the saturation is about 97%. And so if we will do this correction, we will find out that the exact value is 19.5 ml per deciliter. In venous blood, here the saturation is 75%. So here also, if we will do the correction, we will find out that here the oxygen amount is 15.1 ml per deciliter. So finally, if we have to calculate the amount of oxygen in arterial blood, we now know that there is 0.29 ml per deciliter of dissolved oxygen and 19.5 ml of oxygen is hemoglobin bound. So adding both of these, we get a total value of 19.8 ml per deciliter. This is the amount of oxygen in the arterial blood. Now let's try to understand what is this extraction ratio. So in this figure, now we know that 19.8 ml per deciliter of oxygen is in the blood and about 15.2 ml per deciliter is in the venous blood. So if there is any tissue, can you tell me how much of oxygen was extracted from the arterial blood? We will subtract these two values and we will find out that 4.6 ml of oxygen was taken up by the tissues. So this is the amount that is taken up by the tissues. So now if we have to find out the extraction ratio, this ratio is the division of oxygen uptake by oxygen supply. So oxygen uptake here is about 5 ml and the oxygen supply is about 20 ml. So dividing these and multiplying it by 100, we find out that the extraction ratio is 25%. Important to remember. Now let's finish this video with an interesting question. Calculate the oxygen content in the venous blood of an anemic person whose hemoglobin concentration is 10 grams per ml. Take partial pressure of oxygen in venous blood to be 40 mmHg. So in order to calculate the oxygen content, we need to calculate two things: dissolved and hemoglobin bound oxygen. Dissolved oxygen is calculated using Henry's law. So here we know the solubility, which is 0.003, and the partial pressure of oxygen in venous blood. Why are we taking venous blood? Because look at the question. The question is asking to calculate the oxygen content in venous blood. So we are going to take the partial pressure of oxygen also in the venous blood. So multiplying the two figures, we get a value of 0.12 ml per deciliter. Now coming to the hard part, calculating the hemoglobin bound oxygen. So we know that 1 gram of hemoglobin carries 1.34 ml of oxygen when it is 100% saturated. So now this person is anemic. So the person has less amount of hemoglobin. In fact, it is mentioned in the question 10 grams. So 10 grams of hemoglobin would carry 1.34 times 10, 13.4 ml of oxygen per deciliter. But we have to make one more correction. Since the question is asking about the oxygen content in venous blood, so we know that in venous blood the hemoglobin is 75% saturated. So when it is 75% saturated, the hemoglobin bound oxygen will not be 13.4 ml, it will be 10 ml per deciliter. So finally, we have the dissolved oxygen and the hemoglobin bound oxygen. We have both the figures, and after adding this, we get a value of 10.1 ml per deciliter, and this is our answer. That's it for this video. If you have any doubts, so please leave them in the comments, or you can message me on Instagram anytime. The link to my Instagram is in the description. Thank you.